Good morning to all. Myself, Prabha K, working as Assistant Professor in the Department of ECE, Sai Vidya Institute of Technology, Bengaluru. Today we'll discuss on how to use the CRO for the measurement of voltage, time period, and phase difference. Voltage measurement. Assuming that a sinusoidal signal is given to the CRO, then the CRO display will show this graph, which consists of a sinusoidal signal with peak-to-peak voltage and a proper time period to cover one complete cycle. This is the voltage per divide knob, which has been set to 1 in this example to get this waveform. Then, to measure peak-to-peak voltage, we need to have the knowledge of the total division covered by the positive peak to negative peak. In this case, it is 4 number of divisions has been used to cover a positive peak to negative peak. Then the volt per division knob is positioned to 1 volts. Then peak-to-peak voltage can be calculated using the formula vertical peak-to-peak divisions into volts per division. That is given by 4 into 1, 4 volts. This is the total amplitude of the signal from positive peak to the negative peak. Then Vm can be calculated using the formula V peak to peak divided by 2, and Vrms can be calculated using the formula Vm by square root of 2. Time period and frequency measurement. Consider the same sinusoidal signal which has been applied to the CRO. This is the waveform which consists of peak to peak amplitude and a time period taken by the waveform to complete one cycle. Using this time period, we can find out the frequency. First, how to measure the time period? The time period is obtained by the number of horizontal divisions per cycle into time per division. The time per division can be obtained with the help of a knob, which we call it as a time per division knob, which will be set to get this desired waveform. From this graph, it is very clear that total six total 6 divisions have been covered by the waveform to cover one complete cycle. Then the total time period is given by 6 into 0.2, where 0.2 is the knob position. Knob is set to 0.2 second. The total time period of the waveform in this example is 1.2 seconds. Then the frequency can be calculated using the formula f is equal to 1 by t. In this case, it is 0.833 Hz. Similarly, consider an example where your time division is set to the time division is time per division is set for 50 milliseconds. Then the total time period is given by total number of divisions taken to cover the one complete cycle into knob position, that is 50 milliseconds. The total time period is 300 milliseconds, and the frequency can be calculated using the formula f is equal to 1 by t. Phase difference between the two waveforms of the same frequency can be measured using the CRO in two ways. First method. Consider a graph where the two sinusoidal signal has been given to the two channels of the CRO, and both are having a phase difference. Here, this is the waveform A having the time period as TA, and this is the waveform B having the time period TB. Both the waveforms are having same time period. Ultimately, they have the same frequency, but the amplitudes are different. Here, 6 divisions are covered to complete one cycle for each wave. So, 6 division is considered as 360 degree. Then, for one division, the degree will be 60. Then the phase difference is obtained using the formula phase difference in divisions into degree per division. In this example, the phase difference between the two waveforms is given as 1.4 divisions into degree per division is 60. It is 84 degrees. Phase difference is also measured using another method. It's called as a Lissajous method. In this method, two sine waves of same frequency is applied to the CRO. One is applied to the vertical plate and another is applied to the horizontal plate. And CRO is set to the operating X5 mode. The Lissajous patterns are called as a Bromwich curve pattern produced by the intersection of two sinusoidal curves, the axes of which are at right angles to each other. Lissajous used a narrow stream of sand pouring from the base of compound pendulum to produce the curves. These Lissajous patterns have two applications to analyze the signal. First one, to calculate the phase difference between two sinusoidal signals having the same frequency. Second one, to determine the ratio frequencies of sinusoidal signals applied to the vertical and the horizontal deflecting plates. Here, when we apply the two different signals which are having the same frequency to the vertical plate and horizontal plate separately, and CRO is operated in X5 mode, if the phase difference is between 0 to 90 degree, we will get this type of pattern. This is a Lissajous pattern. Then please obtain the distance A, that is the intersection of wave with the y-axis, and the maximum value in this, I can say in the first quadrant, that is a B value. Then the phase difference between the two signals is obtained with the formula phi is equal to sine inverse of A by B. If the two signals is having the phase difference of 90 to 180 degree, then we are going to get the phase on the Lissajous pattern in this way. The intersection of the wave with the y-axis is taken as A, and the maximum value of the pattern in the second quadrant is taken as a B, and the phase difference is obtained with the formula phi is equal to 180 minus sine inverse of A by B. Thank you.